War. War never changes.
Sorry about that. War never changes, but manufacturing methods do. And I've got a whole bunch of 3D printers. So, why don't we take all this 3D printable plastic and turn it into a set of T45 power armor from the Fallout series. How hard could it be? Let's get started. So last year, I finished probably my longest 3D printing project ever, and that was a set of heavy Mandalorian armor for myself. And I brought this to Earth, I wore it around. This project took me a little over a year to fully complete, and while it's not quite 100% done, for all intents and purposes, this suit of armor is done. I can wear it, I can go out and about with it. It was a great project. I had a ton of fun doing it. However, this year, I wanted to undertake another project. I wanted to undertake something bigger. Now, when it comes to undertaking a cosplay that involves a lot of 3D printing, you have a ton of options. And I had narrowed down the list to a few ideas. Near the top was, for example, a HEV suit from the Half-Life series. That's something I've always kind of wanted, and we may get to that project one day, so make sure you subscribe to the channel so you don't miss out. But power armor was one of those things on that list. And I've been a fan of the Fallout series, but Fallout 3 was the first Fallout game that I really sunk my teeth into when that game was originally released. And the T45 power armor from that game is kind of iconic. So earlier this year, when the trailer for the Fallout TV series was announced, and I watched it, I was kind of sold on what I would be building this year.
So you see, that's where the trouble began. That smile. That damn smile.
Now, yes, the armor in the show is, I believe, the T60 power armor, and I'm building the T45. Why? Because, honestly, I kind of like the looks of the T45 more than the other variants of the power armor in the Fallout series. I like the more angular look. It's a little bit more of a slim look. It's just, you know, build the thing you want to build. It's your build. I like T45. We're building T45. So, first things first, I can't CAD myself out of a cardboard box, so I'm gonna have to find some files and then print them. So let's do that. Now, when it comes to getting your files, there's tons of different sources out there, various different websites and repositories. For example, the Mandalorian armor that I built last year, I got the files from Galactic Armory. Great files, they work perfectly. For the T45 power armor that we're now building, I got my files here from CG Trader from 3D Printed Universe here. So I purchased these files, I downloaded them. Now, one thing you need to pay attention to is when you go to print your files, I'm a different size than you. I guarantee it. Unless you have, you know, the person who designed this armor designed it with you in mind, odds are it probably won't fit you perfectly, and there's a few different ways around this. Now, you could do what I did with my Mandalorian armor when I printed that, and print a few pieces as test pieces, adjust scaling, and then go from there. Another option you have is you can purchase some software here called Armorsmith. This allows you to essentially make an avatar of yourself by inputting your measurements, and it'll allow you to play around with your 3D files and scaling to figure out how big the files need to be to fit you properly. So for the T45 power armor, I'm doing neither of these. I am printing it as is, and I'm going to do something different. I'm going to make myself fit the armor. And the reason I want to do that is I really like the look of the T45 power armor, and part of that is the scaling. Everything is kind of in proportion to each other. With the power armor, I printed the helmet, and the helmet as is fits me pretty good. Usually I print the helmet first, get that size good, and then I base the rest of the armor off of the helmet. That way you don't really get that bobblehead effect. Too big of a helmet, too small of a body. That was something I really wanted to avoid on the Mandalorian armor. So that helmet, by the way, when I wear it, is pretty much touching my nose. There is no extra room in that helmet. The power armor helmet, I printed it as it is, and it's pretty much the right size. So if I were to start scaling some of these parts down to fit my body, I'm gonna look like a bobblehead. I don't wanna mess with the proportions. So instead, what I'm gonna have to do is get pretty creative, and somehow I'm gonna have to grow a couple inches to make this fit on me properly, and we'll figure that out in part 2. So we've gone ahead, we've downloaded all our files here. So we're just gonna load them up in our slicer here and start printing. Oh my God, that's a lot of files. So obviously when you start printing your files, you're gonna wanna split it into groups. If you have multiple printers, it'll make printing things a lot easier because you can have multiple files going at once. Obviously, you're gonna wanna group stuff together. You're gonna wanna keep track of what you're printing. And as you can see here, there's quite a few files that won't fit on the bed. And for example, this bed is my 300 spec 4 on V2. So while a lot of it will fit on the bed, quite a few parts, as you can see here, 486 millimeters tall. Yeah, that's not gonna fit. So we're gonna have to split some stuff up. So when you want to cut or split a part into multiple pieces to make it easier to print, or just so it can actually fit on your print bed, you do have a few options, and most of the modern slicers, at least those based upon Bruce's slicer, have cut tools built into it. So that's what we're gonna do here. So I'm using Orca slicer, which is based on Bamboo slicer, which is based on Bruce's slicer. It's elephants all the way down. And the first thing I'm gonna do is just orientate my part here so it's vertical, and then we're gonna get our cut tool. We're gonna wanna make sure that we keep both parts here, obviously, and we're gonna cut it at a place where it'll fit on the bed. Now, I like to cut the parts basically where it's as simple and as flat as possible. You don't want to do your cut here because then blending out the seam line is going to be kind of annoying. So I'm going to cut right about here. You don't want it like this because then when you print this part's going to be really thin. You do want a little bit of stiffness to it. I just find it's easier when it comes to mating everything together. So we're going to cut it right about there. I think that's good. But before we cut it, we do have a few different options for how we put these back together. So if I were to cut it as it is right now, you're going to be relying on your Mark 1 eyeball to just visually line it all up, get some clamps involved, and just kind of hope it lines back up. But we can make this a little bit easier by adding some connectors. And what I like to use is dowel connectors, 8 to 10 millimeters deep and 2 millimeter size. And you might be wondering what are the dowels we're going to be using. It's just going to be cut pieces of filament, because it's just to help line it up. When you're acetone welding or glooping stuff together or using epoxy, those adhesives are going to be plenty to hold it together, and the dowels are just going to kind of line it up. So we'll put some dowels in, confirm the connection, and then we're going to perform our cut. Now, what the slicer will do, it will usually give you the dowels on the bed. You can see them right there. We don't need those because, again, we're going to be using some filament, so I'm just going to go ahead and delete those. And when it comes to orientating your part on the bed, first off, this is great now because our two halves have these nice flat surfaces because we cut it. That'll sit nice and flat on the bed. Great. Now, I don't like reorientating parts. So what that means is if this shin here, if I'm printing this part vertically, I don't want to print this part on, say, this orientation. Okay, so even though, depending on how the part cuts and the geometry, sometimes it might be more beneficial to print it this way. I like to print the parts all in the same orientation. I just find when you go to assemble them later, they kind of just fit together better. I've tried both and I had better results this way. So obviously this part is still too big to fit on the bed, so we're gonna have to go and split this down again. I would say probably split it about here. And for the part on the bed, the print settings I like to use, again, I'm printing in ABS. I like to print things as rigid as possible. So I'm using near Voron spec print settings. You're gonna wanna use a lot of walls, especially on thinner parts like this. So I used anywhere from 3 to 4 walls, 5 top, 5 bottom, with about 20% infill for the most part. And when it comes to support, I like using organic support, only supporting things that need it, and especially only parts that are visual. If it's not visual and you're not gonna see it, why spend the time on it? And also, print with a brim. Yeah, you might not always need to print with a brim, but when you are loading up a full plate of parts, the last thing you want is a print to fail or a part to fail dozen hours in because it started warping off the bed. It's a lot quicker to clean off a little bit of brim than it is to reprint an entire bed of parts. So after you're all happy with all your settings, you can go ahead and slice everything and get printing. And however long it takes to print is however long it takes to print. When you have a lot of parts, you know, the temptation is always there to rush your printing, but I find it's better to be a little bit more precautious with your settings, err on the side of caution, because a print that finishes is a print that finishes. It doesn't matter how fast a print is going. If it fails to finish, it's still wasted time. So I like to be a little bit more conservative. If you want to print faster while being conservative, just get more printers. Simple as that. Now, when it comes to what plastic you should use for printing your 3D printed parts for your cosplay, or in this case power armor, you have a few different options. The big three plastics you're going to see with FDM are PLA, PETG, and ABS/ASA. I'm just going to say ABS in this video, but when I'm saying ABS, most of this is either ABS or ASA, and that's right, pretty much the entire armor that I've printed is in ABS or ASA filament. And I went with that plastic for a few reasons. One, most of the machines that I printed everything on are fully enclosed machines. I've used mostly Bamboo X1 machines along with my Vorons to print this power armor. And the reason I didn't go with an easier to print plastic like PLA is severalfold. Now, PLA, for those that don't know, is probably the most forgiving plastic to print in FDM. It's very stable. You can print it open air. You don't really have to worry about warping. You get really good crisp details because you can just blast it with cooling. And this Stormtrooper helmet here is printed in PLA. And PLA is great, but in my opinion, it's not really the best plastic to use for a project like this. And there's several reasons why. Namely, PLA is very, very stiff and rigid, which at first you think is great. You know, my part's nice and tough. Unfortunately, that means it's also more prone to cracking. And if you're wearing something and you're kind of moving around in it, you might kind of bend apart a little way. With ABS, you have a bit more forgiveness. If you bend it, it just kind of bends back. You have to bend it quite a bit before it fails. Also, PLA by itself is really hard to post-process. It doesn't sand great. ABS, on the other hand, you could take a sander right to this and start knocking those high edges down, those layer line down, right out of the machine. PLA, usually you have to go in with some sort of spot filler to fill in the more rough areas before you even attempt to sand it. Also, nobody wants to spend hundreds of hours working on a set of props or cosplay, leave it in their car on a hot day and come out to it melted and deformed. ABS is a lot more temperature stable. You can leave this in a garage on a hot day or in a car on a sunny day, and you don't really have to worry about it melting on you. So another downside for PLA. Now, PETG, I've never actually really tried printing cosplay or props with it. It's really gummy. You can't print it as fast, and I have the ability to print ABS reliably, so I use ABS more. So all the big 3D printed parts for this project are in ABS or ASA. Now, another good reason to use ABS or ASA is when it comes to attaching the parts together, and I've got two examples here. For this shin guard, obviously this was way too big to print on any of my machines, and you can see it's actually printed in 4 separate parts. And these parts are held together with nothing but acetone. ABS, you can acetone weld. And once you acetone weld it together, which is a very simple process, you just use a little bit of acetone. I use small acid etch brushes. You apply it on the seams, you push them together, you hold it for a couple seconds, you let them set for a couple minutes, and this is one solid homogeneous part now. If I snap this, it's going to snap somewhere where there's layer lines. It's not going to snap at the acetone joint. So that's how I attached most of the main body armor for the power armor together. Now, for the helmet, I tried something different, and actually I want to give a shout out to 3D Gloop at this time. They sent me some of their ABS/ASA gloop, and I used that to attach the helmet parts together. Now, this helmet was printed in a dozen plus parts easily, and it's still not fully assembled, but this helmet was all attached with 3D Gloop for the parts, and I found the 3D Gloop works a bit better than just pure acetone. It seems to penetrate a bit better, and it's a little bit thicker than acetone. Acetone is pretty much like water. So with it being thicker, parts that didn't align quite right, I had better chance of getting them to stick together than I did with just pure acetone. And then of course, any small gaps and whatnot are going to be filled with Bondo or spot putty later on. Now, while this build wasn't sponsored by Polymaker, I do want to give them a huge shout out. Pretty much most of the filament that you're seeing here, especially all this black filament here, was provided by Polymaker for this channel for projects. Now, they're not sponsoring this video, but if you do want to check them out, link in the video description. It is an affiliate link, but it doesn't cost you anything extra and goes a long way in supporting the channel. So if you're looking for some good quality 3D printer chow, be sure to check them out. Now, in a perfect world, whenever you load a 3D printed part up on your plate, it'll just print as is, you just hit slice and go. But unfortunately, Nobody's perfect, and you're probably going to have to use some supports for a lot of this. A lot of cosplay stuff is random oddball size. The chances of it just sitting perfectly flat on your bed and printing as is are pretty slim. So a lot of my parts that I printed here, I use support, and luckily Orca Slicer has organic supports. Thank you, Prusa Slicer. And organic supports are great. They just kind of support everything you need to support, and they break off so clean with minimal work. And the advantage I found with organic supports is they seem to print pretty quick compared to other support methods as they branch out as they get to the areas they need to support, and further down on the bed where they're just starting. They don't really use a lot of material. They break off really clean, and unless you have some sort of regrinder at home to re-extrude this into filament, support is pretty much waste material. It's going right in the garbage. So you want to use as little of it as possible. I love when they come off that clean. So this right here is just the support that I broke off of that little ab piece and one of the arm pieces. And you may be wondering, you know, with 35 pounds of 3D printed parts for this armor, how much material am I pretty much just chucking in the bin? Well, about this much worth, which, including the box, weighs more than my scale can weigh. And this thing is rated for 5 kilograms. So yeah, you're gonna have failed prints. You're gonna have prints that, you know, unfortunately you open the door midway through and they just cracked in half because, again, printing with ABS. You're gonna have a ton of support material. You're gonna have parts that just didn't come out the way you liked it. Unfortunately, a project this big, it's gonna generate waste. However, you can minimize waste in a very clever way. You know all those partial spools of filament you have kicking around that have like 50 to 100 grams of filament on them, and there's not enough to really do a big project, but there's not so little there that you're just gonna chuck the spool? Well, with the AMS and a lot of other multi-material systems, like the Enraged Rabbit Carrot Feeder, you can do what's called filament rollover. And that's what I was using on the Bambu Lab X1 for the parts that I was printed. And what that means is essentially you can load this up and you just trick it in the slicer. You simply tell it that it's loaded with 4 banks or 3 banks or whatever of the exact same plastic. So I just told it black ABS from Polymaker, right? And luckily, since it's all ABS and ASA I was printing, the temperatures, everything printed okay. And what it will do is it'll finish off those partial spools, and the moment it's empty, and it will finish off the spool, it'll just switch over to the next spool. And then when that spool's empty, it'll switch over to the next spool, so on and so forth. And the best part is, if you finish off a spool mid-print, you can actually just take that spool out, grab another partial spool, throw it in, get it started, and it'll switch back to that after the one it's currently feeding from is empty. So you can be pretty efficient and use up a lot of partial spools if you're printing something that's going to be post-processed. So for example, this boot cap here was printed in 5 different types of filament. These were all 5 partial spools that I just had kicking around collecting dust. I believe this is a dark gray ASA. We've got Polymaker red ABS, Sparta 3D Galaxy orange ABS, a generic black ABS of some sort, and Polymaker purple ABS. These are all partial spools used up printing this one boot, and the colors don't matter because this is all getting post-processed and painted anyways. Now, if you don't have a system like this where you can do filament rollover, whenever you're printing a big project with a lot of filament on the plate, it's always a bit nerve-wracking when that spool starts to get empty, and you might have enough to finish the print, or you might not, or it's 2 in the morning and you're not even there to check it. Well, one of the other ways I got around this, and this is what I used on my Voron V2 that I was printing a lot of stuff on, I just got really big spools of filament. So these are the 5 kilogram spools of ASA filament from Polymaker, and I went through 2 of these, almost 3, printing the part. So when you see the power armor laid out and while I'm working on it, just to give you an idea of what was printed on what, anything that's multicolor was printed on my Bambu Lab X1 with the AMS system doing filament rollover. I managed to finish off I think about 16 or 17 spools of filament using this method. And a lot of them were little partial spools like this. And anything that is solid black was printed on my Voron V2 300mm spec. And if you're wondering how long it took to print everything, about 2.5 weeks. So I've got everything printed now. As you can see, it is quite a bit. We're about 35-ish pounds of 3D printed parts as it is right now. I've gone ahead and patched all the various sub-assemblies together. So let's lay them out on the floor and see what we're working with. Okay, say hello to my messy garage floor with all the Nerf darts that are absolutely everywhere. Yeah, let's lay out the power armor and see what we're working with. And if you're wondering, these boxes here, this is all the back pieces of the armor. So this is just the front. So yeah, as I said earlier, it's about 35 pounds of 3D printed parts. And that's before we do any of the post-processing to finish it. So no Bondo on it, no epoxy. Some of the bigger parts, I'm gonna do some fiberglassing on the back of it to give it more rigidity, more durability. The last thing you want is one of these big parts snapping on you halfway through wearing it. Got to fill in all the little cracks, nooks, and crannies, get rid of the layer lines, start painting everything. And of course, this is supposed to be a wearable suit of armor. Right now, it's just a pile of 3D printed parts on the floor. So in the next part, we're going to start turning it into that. So make sure you're subscribed to the channel so you don't miss out. If you have any questions or comments, be sure to leave those below this video. Make sure you're subscribed to the channel so you don't miss out on the continuation of this build series. And if you want to help support the channel, the content I create and the things I do, don't forget to check out the links in the description. Consider becoming a channel member or a Patreon supporter. I hope you enjoy this build series. I look forward to finishing it. This is going to be a ton of fun. And as always, I'm Nero3D, the Canuck creator, and cheers.